So today we're going to start Chapter 8, Section 1, and in this lesson we're going to learn about similar polygons. So here, when you have corresponding parts of similar polygons, the angles are going to be congruent, but the corresponding sides are going to be proportional. Now, when we had the congruent polygons, everything matched perfectly and it was exactly the same size. When I have similar figures, one will be a smaller version of the other one. So it's going to be a big one and a little one. It's going to have the same shape but different sizes. And the symbol for similar is what's usually on top of the equal sign for congruent. It's just this little wave looking thing. So this is the symbol for congruent, not congruent, for similar. And that's what's right here in the statement in the box. So they're telling me that these two quadrilaterals, ABCD and MNOP, these are similar quadrilaterals. They're actually trapezoids, but we're going to cover a chapter on quadrilaterals later. So based off of this statement, you can tell which angle matches with which angle. So the order matters. So for example here, notice the first letter is A, it matches with M. So I could put a congruency mark on A and M that looks the same. Then the second letter is the B, and the second letter here is the N. So I could put same type of congruency marks on the N and the B. Then the third letter is the C, and it matches with the third letter here. So 1, 2, 3, 1, 2, 3. Guess those are hard to see. Let me do it. I'll go over it in black so you can see it a little bit better. 1, 2, 3. And then the last letter is the D, and it matches with the P. 1, 2, 3, 4. 1, 2, 3, 4. So I can show here that each of the angles are going to be congruent. Notice the statement that was listed individually. So if it asks you to list all the corresponding parts, you would show all the angles are congruent. However, the sides are not congruent, they're proportional. But we're still going to match them, but we're going to write them as ratios, or in other words, fractions. So if you also refer to your statement, notice the first two letters over here are AB, and you could match AB with MN, and that's what was put in this ratio. Again, I'm not going to add congruency marks because they're not the same size. And then you can see that BC, that's the second and third letter, and it would match with the NO, and that's the second ratio that's here. This is your statement of proportionality, if you're asked to give that in a question. And then lastly, the third one, this third side is CD, which are the last two letters here. So the last two letters here, and that's the CD equals OP. And then finally, they went from the beginning to the N, the A to the D, so then the M to the P here. And again, that's your last ratio, that's right there. Let me get rid of that gallery. This figure, I add, and this isn't in your picture, just you can add them. Let's say this side is 6. Let me do it in a color that shows up better, 6. And then let's say these two sides are 8, and this is a 10. And then over here, 3, 4, 4, 5. Now, because the sides are proportional, what we would need to do is make sure that when I put them together that they simplify to the same ratio. So for example, using this proportionality statement, if I take side AB, which is here, the 6, and I put it over MN, and then I reduce that, 6 over 3 simplifies 2 to 1, or just 2. Then if I do the same thing for the BC, BC is 8, and then NO is 4, That one also simplifies 2 to 1. And then I have to check the CD over the OP. 10 over 5 simplifies 2 to 1. And then lastly, the AD, which is 8, over the MP, which is 4. And this one also simplifies 2 to 1. If you match up the corresponding sides and they're not proportional, if they do not simplify to the same ratio, then these are not similar. Every side needs to simplify to the same ratio. So a lot of times they're going to use similar figures, like maybe they have a model of the Empire State Building and maybe they tell you it's drawn to scale. So they would have the same shape. They would both be Empire State Buildings. You would compare it to the real one and then maybe just a model or a souvenir, and then everything would be proportional. All the sides would correspond. Okay, let's try. So what we just did by finding that 2 to 1, that's actually our scale factor. And it's going to be a simplified ratio. So you also need to pay attention to the order of the similarity statement. So for example, if I said, find the ratio of the corresponding sides of the two similar polygons. Now these are both equilateral, and notice every time I do 3 over 6, it simplifies to 1/2. Now, if they ask you to find the scale factor, watch the order that they put the statement. So if they say, find the scale factor from ABC to DEF, then what you would put here is the measurement of the smaller ABC to the larger one, which is 6, and this would simplify 1 to 2. Remember, there's 3 ways to write a ratio. You can either write it with the word TO like I just did, you can write it with a colon, or you can write it as a fraction. Now, if you would have told me that the scale factor for this question was 2 to 1, you would get it wrong. Now, if the question was changed, and if it said, find the scale factor from DEF to ABC, then you would put 2 to 1. So the order that the letters are listed will be important, that you list your ratio in the appropriate manner. Always remember to simplify your ratios. It wants us to find the scale factor, and again, watch the order. So from the larger quadrilateral ABCD to the smaller one, MNOP. Now, what I need to do is figure out which side matches with which. Now, in this picture, they're sitting exactly the same way. You have to be careful because sometimes they might turn one of the figures on its side or turn it upside down. And the way that you can tell which side matches with which is what you would do is look at the order of the letters in the statement. So you see how AB is the first 2? So it's going to match with the first 2 letters here. So AB matches with the MN, and that's going to be 12 over Y. Then if I want to see what matches with AD, I'll come over here. See how A is the first one and D is the last one? It's going to match with the first and the last here, so it's going to match with the MP. Now, what I'm looking for in this, when I have some sides that are unknown, I'm looking for the pair that has both a number for each side length. So notice from the larger one, AD is 10 and MP is 8. I can get the scale factor using these 2 sides. So I could take 10 over 8, and I guess the blue's showing up. So 10 over 8, I'll do it up here. 10 over 8, and this will simplify to 5 to 4. This is